Regions in the plane. Basically, it's inequalities. Or inequations, if you like. But instead of with one pronumeral, it's with two. And so instead of just having it on the number line, we have a number plane. So we have an area. So in order to do this, we have to find the region. We're going to need the boundaries, and the boundaries are usually one of our basic curves. Now once we've got that, depending on the type of inequation, whether we dot the line or make it solid. If it's just less than, we traditionally dot it to indicate the boundary is not included. If it's equal to as well, then we go, okay, I'll draw a solid line to indicate the boundary is included. Now the point of intersections then create a problem. Basically, there's only one way the point of intersection can be included, and that would be if both boundaries are included. Because both inequations have to be correct. Now, if one of the lines is dotted, or both of them are dotted for that matter, then we should circle the point of intersection to indicate, hey, this point of intersection is not included. Yeah. And then we can just test a region. So you just grab any point which is not on the curve, and we sub it in and see if it works. So let's start with a very basic one. It's just a straight line for our boundary. So we draw in y equals x plus 3, but we draw it in dotted. There it is. And then we pick any point we like that's not on that line, but we like to make life easy for ourselves. So which point do we pick? 0, 0. Got to be the easiest point to substitute in. So let's sub it in. 0 is less than 3. Is that correct? You want to try again? Yes, it is. So, we're in that region over there, and we shade that one in. Okay. X squared plus y squared greater than or equal to 9. So we're talking about a circle. So the boundary, whee, there it is. In this case, we're saying, look, are we inside the circle or outside the circle? Again, it's broken up into two areas. I can choose 0, 0 again because it's not on the circle. 0 greater than or equal to 9. No, so we're on the outside of the circle. Okay, or this is always a good one. Y is less than the square root of 4 minus x squared. What's the boundary? But what's the basic shape I'm looking for? It's the semicircle first of all. There it is, dotted. Test naught, naught. And so naught is less than 2, which would seem to imply we're there. Problem is, it's like there's no boundary underneath here. It's like it could all just spill out and go everywhere. So we need more boundaries. And that's all to do with the domain. Notice those boundaries on the domain are not dotted. They're solid. Right? Because, and if you're ever in doubt, go back to the original inequality. If you sub in any point on that line down below, so the y value will be negative, I really don't need to know what the x value is, because if the y value is negative, it's always going to be less than the positive square root of something. Yeah. So any point in the, with the x value being in the domain, will always satisfy that inequality below the x-axis. If it was greater than, then obviously the lines would go up instead of down. Technically, there's something I should have done and haven't. I should have circled. Well, should I? Is it included or not? No. Because 0 is not less than 0, it's equal to 0. So I should have circled that. Well, let's try one where we do have an intersection of two. So I've got the parabola and a straight line. So the first one I'll draw is my parabola. Now, I'll test a point. Can't test naught, naught, not on the parabola. Damn. So I have to pick a point where I know its location related to the parabola. I probably picked, knowing me, 0, 1. Because I know that's inside the parabola. So I know its location. Let's see. Yep, 0 is less than 1. So I know I'm inside. But I don't shade it yet. What I do is just sort of mark in some crosses so I know, right, I'm inside, so I've marked some blue crosses there. Now I'll do the line, which is also solid in this case. I can use 0, 0 for the line. Now, to find those points of intersection, obviously we solve simultaneously, so we know what they are. But let's check it. 0, 0. Yes, it is. So really the question now is, where do I have both red crosses and blue crosses? And that's the region that I'm interested in. And so I'm just in there. Ah, good point. Yeah, technically they should be dotted, shouldn't they? Because they are not part of the solution. There you go.